Then I guess I can get started. I can stand if you really want me to. So on the next slide, from Lawerence, Livermore. For about 3 years now, I was at Los Alamos before that, which is why I tend to use Charliecloud, because I want to be compatible with Los Alamos workflows and all that stuff. But I guess right now I'll be talking about how I've worked Charliecloud into our GitLab-CI workflows to build system representative-based containers for use by myself, code teams, anybody. So go through the overview. So we wanted to do this for a few reasons. I think it's advantageous to have portability, at least within the DOE, because we have some requirements to be able to fail over to other systems, or just to make things easier for the users of running on one system and being able to move to the other if they want. Reproducibility is nice in that even if the system starts updating and things start changing, we could have a static container that keeps most things in the same shape. And so if something breaks your application, you could use a container of an older version and hopefully still keep going. And there are plenty of established external workflows that use containers. And as we just try and bring those into the lab and run with them, try and make that work. And it isn't always perfect. So tend to start with hopeful, then you run into blockers and get sad at the end. AI helpfully generated some faces for me, even though I told it no hair. So there have been a few issues that either users have run into or I've run into as I'm trying to bring containers into our systems. Like if you're pulling in just a generic Ubuntu-based container, you can't get much support for it. Our admins are building a RHEL-based OS. They're supporting that. They're not trying to figure out how to get your libraries on Ubuntu for whatever random version and container you have. And they don't want to spend too much time trying to reproduce your environment, get into it, and figure out why that issue is happening on their systems. They'd rather you just run on their systems or run something that's closer to what they're used to. And then there's obviously institutional tools that are provided that are geared towards what is supported, and then everything else is maybe it'll work. If it does, cool. If it doesn't, try something else. And I guess, yeah, so external containers are not in the thought process when they're doing these things. We have a couple different types of systems that we're targeting on site and within the tri-labs. We have our commodity systems that are just like, we've designed and worked with vendors to come up with a generic thing that we can scale up in large units as needed and as many as available. Intel CPU maybe has the option for GPUs if we want regular Omnipath and no vendor supplied environment. So we get what the OS gives us and we build out everything on top of that, in this case using SPAC. And it's Slurm scheduled at the moment. We'll want to move to Flux because we've made Flux and we want to use it. And because we think it has good scaling and other uses like that. And then our ATS systems, the leadership class, advanced technology systems like LCAP, have AMD APUs of CPU, GPU co-located with a single memory. Cray Slingshot is a giant thorn in the side if you're trying to make things work with other things. They do provide a substantial programming environment, so they provide all the compilers, the MPI, a lot of the libraries and tools, so that reduces the workload that we have to provide, but we also have to integrate with that programming environment to make something coherent for the users. And in this case, it's Flux scheduled. So the idea here is trying to make a container that could work on both or even just one of those. Has lots of complications of integrating with the variety of different tools that are used. Luckily, at our site, we use TOS on all of the machines. So if we start with a TOS module or a TOS container, we can run that on either one, and it's a common use case with the system, and it will be compatible with the system if we just keep using TOS RPMs for anything too integral. And so both of the systems can use the CTS RPMs for like GCC or Git or curl, whatever. And then Cray provides extra RPMs because we force them to, that aren't the SUSE things they're used to, but they're providing it for Red Hat because that's what we put in the contract. And the TOS does have a pretty regular update cadence of monthly, but it's usually small point release that's not too big of an issue, but it has happened before where, I don't know, it may have been on Cray OS back when I was at LLNL, where it updated a version of a library that was very low level, and all of a sudden everything was breaking, not able to find its dependency. So that was fun. And so trying to keep up with all those things are issues that maybe we can avert having these containers for TOS. So I build very minimal base containers in GitLab and host them within our lab in a way that they can be anonymously pulled. So you don't have to log into GitLab, because we also have GitLabs where you don't get to make things publicly available. So for the bare minimum level, I have Red Hat based images. It's really Red Hat based, and then I start with UBI, create a new root in that container, and then bootstrap from that for the subsequent containers. But it has all the repos specific to these versions. So if you wanted to use 4.8-2, it's pointing at the path for the RPMs that were used in that version. So it's not pulling in more recent ones. It will represent what the systems look like at that time. And then I guess another point is TOS releases these things, and then it takes 2 or 3 weeks to get to our systems usually. And it depends on which network you're on. They may be out of step with each other. I can, like, upon release for a given version of TOS, I can build the container for it, and then a code team could then pull that in and start testing their code against it before it even hits the systems to try and get a head start on any issues that may pop up. Of course, if you're trying to target our machines, it gets complicated quickly. So on those base containers, I've started adding containers that have a single compiler or a single MPI, so that a user could pick one out and run with that and have a sensible environment, and know that it has been tested on our machines to leverage those resources. So it's multi-node, it can use the GPUs, all those kinds of things. And so having like 6 compilers for ATS, 1 Kring pitch is at least nice. I only build 1 for any given TOS version, 1 ROCm also for any given TOS version. So those avoid the multiplicity issue. But as the TOS versions come out, that just keeps accumulating more and more containers. CTS gets a bit more complicated. It doesn't have the GPU portion, but it does have 5 compilers and then multiple MPIs, and keeps going from there. So we're already up to 100 or 200 containers, depending on what system you're targeting. And like I said, TOS releases come out every month. So that will keep piling up. But there's not a need to continue necessarily rebuilding those every time. Once they're built and they're tested, you could just retest that container every time there's an update and make sure it still works. So there's work on making that a little less cumbersome. And I've set up the environments on these so that you're not using modules to access any of the software I provided. I've installed the compiler, I installed the MPI. Those are in your bash environment when you log in or when you enter the container. So it's just there ready for NPI-CC to build whatever you want. And I think that just makes for a little easier workflow, considering you don't have to worry about multiple versions of everything. And then one of the use cases I have with this is I build our programming environment inside of this. So I build it in chunks. but eventually it does end up being 800-ish packages in SPAC, and we don't get rid of much software, so that's only going to grow. And we will rotate over at a TOS update, perhaps. We'll trim out some of the old compilers if we can really talk our code teams into it. But that's one of these challenges. And the containers have been helpful in this, in that SPAC has a few issues when you've got too much going on, as one of the talks talked about earlier. Breaking it into compiler-specific builds is very helpful. The concretizer will start mixing different compilers in a single spec. You have HDF5 MPI built with Intel, but it'll depend on something with GCC 11, and then something else underneath that will be a different Intel, and it just, I don't know why, and it's hard to specify, or at least at the time it was, how to lock that down. So breaking it up into individual compiler containers helped. And then we just bring those concretized environments together in one, use the build cache that was generated with each of those, and just make a solid single environment that is coherent, and the modules and views and everything can be built with that. We also want to use this to automate and test the builds, because right now it's an awful process. I've got another talk about that this afternoon on the SPAC side, but it's very cumbersome. We have one, maybe two people at any given time that could do this. And there's plenty of people that have different requests coming in. And it would be nice if I could just say, like, go make the branch yourself, try it, see if it breaks, and then we'll talk at that point about whether it's worth the amount of work to go into it to add that package. And then obviously portability helps. Another use case I've had for this is building the AI/ML workloads on our machines. PyTorch is nice, but getting it to work with ROCm has been difficult, and ROCm has constant updates, and you keep trying, and maybe something else is fixed, maybe it's not. And Cray Slingshot is also something PyTorch doesn't care about, so they don't know about it. There's an AWS plugin to make RCL RCCL work with Cray Slingshot. Neither PyTorch nor AMD want to claim that. So that just keeps sitting out in this empty ethereal space, hopefully staying up to date with our machines. So being able to, so I've got a workflow to build this, and I can test that with new releases and test those containers on the machines to make sure it works. And then I push up pip wheels into an internal server so that users could just pip install that and get something that does work, because even if you pull the ROCm specific one from the public PyTorch website, it's just going to not be able to work multi-node. It'll be very locked down to whatever version of ROCm they were targeting, and you don't know if it's necessarily going to be very performant on your specific architecture type. So having this CI workflow, I can build this on our machines and deploy it pretty easily, automatically. And then obviously containerized production applications is something that we're trying to pursue. All the three labs are working on presenting at least a specific code that they've been able to do this and have it work at other laboratories. Some labs are ahead of others in getting that done. Some labs want to try multiple apps. And I think I've been able to show that these TOS containers work on a Cray OS machine, because it's still got Slingshot, which is the big issue between our machines and their machines, maybe, is the fabric. And since that's common, we're able to be portable there. And so within that, we're slowly making the strides towards having a common container that can work in multiple sites and show that the production workloads can work. And we have a colleague of mine at Los Alamos has been able to take one of these containers, build their application, and run it at our site and theirs from the same container. So we're slowly showing that that can work. So I guess that's basically all I've done for this kind of Charliecloud stuff. Oh, it's supposed to be more about Charliecloud. Sorry. So why did I use Charliecloud for this? I guess, like I mentioned, I came from LLNL, so that kind of helped. I knew the Charliecloud team, so I can always harass them directly if I have any issues. So that's nice. But also because we want these containers to be portable across the sites, I don't see why we wouldn't just use the same container workflow at the different sites. Charliecloud containers can be run by other runtimes, so it should be fine if they want to use a different one. But like in my CI workflows, I can just build Charliecloud and then use that at the different sites and have a coherent workflow. Of course, it doesn't hurt that it can be installed by any user. You don't have to ask the admins to install something for you. I maintain the programming environment at our site. I don't even keep Charliecloud up to date there as fast as I would like. So I just build it myself for every CI job. But it's nice that you don't have to rely on the admins or me to do that either. Devs are helpful. I'm not paid to say that, but they are. And I get some pushback on this, but I do genuinely find use and value in trying to work with the projects that the other labs have deployed and make them better and not just keep making 3 versions of everything that is still not great at anything. I do all my work on the HPC platforms. I do the builds, the runs, everything up there, converting them, building on top of them. And Charliecloud is great for this. I can redirect my temp storage to wherever I need to, and on different machines that can be in different places. And then system provided dependencies and user provided dependencies can be maintained in these containers, even if the machine keeps moving and something breaks. They're great for that. And it is targeted towards HPC, so they're more receptive than maybe Podman or something like Docker would be towards an HPC specific issue. So Charliecloud's a great choice for this. And if I ever do hit any issues, they're usually pretty responsive. And that does sound useful. We'll try and work on that soon. So that's my experience with Charliecloud.
Yeah. So, okay, so, well, I work at university, and this is, it's a follow on what you said about reproducibility for failover, because like the management and the deans of the various deans, something they've been trying to get going over the last couple of years, well, too long, is cloud bursting from our cluster. They want, they want to see if we can do, if workloads can be burst to the cloud with like reproducibility from, like reproducibility, right? Like work, which like a lot of us are just like, that doesn't work, but we're still gonna, we're still gonna try to entertain that. And so the like, do you find that like, would you think that like a system container of at the level you built, do you think that could even work? Do you think that could work on a public cloud? Like aside from issues of like you're in a national laboratory, you've got these restrictions,
well,
but
we
like
still have people that want to do that as well.
Yeah, but like from a technical standpoint, do you think that that's feasible?
I think if you can set up like an AWS or Azure instance appropriately, you could probably make it work. If not, you could at least have your workflows build both at the same time and test those out and have something specific for each platform that does work and is tested. So I think there are different approaches depending on how restrictive your environment is. I don't know how useful slingshot libraries would be on AWS, but you could at least build a specific one for the architectures you're targeting there and make something work. We have government GovCloud instances of Azure or AWS, and we're looking at if that's even feasible to burst to the cloud. Or, I mean, there's a reason we have our own clusters. It becomes too expensive pretty quickly if you're not leveraging it in the right way.
Yeah.
But if you're only having occasional workloads, that can be more cost effective. So, yeah.
Okay, cool. Thank you.
I have like two questions, and rather different. So first is, I am building these base containers, and it works for you because you're using TOS, and TOS is like a very centralized distribution. But you can't. Can you make? Is there any world where those containers can be public for all of us to play on, or like is this still very much an internal license, whatever?
I guess the only licensing issues we have are anything that is Red Hat specific, because they have their own licensing restrictions, or anything that is Cray specific, so you need licenses for that. I do build two sets of these containers, one that's based on Red Hat UBI and one that's based on CentOS Stream, so that ostensibly the Stream one could be more releasable, less license restricted, but it's still using the TOS repositories, and we don't share those for some reason. So I think we have discussed this, and I think it's possible to split out anything that is too overly license restricted from the rest and try to make that more public and more available. There's interest in this from even SPAC that wants to build for the tri-labs and build up a binary cache that would work for our machines and be able to do that in, say, like the University of Oregon machines. And so they can have a public TOS container that would help. So that's what inspired the CentOS builds. But yeah, I think there is a world where that could happen to at least some degree. And then you could even have your own local, like if you do have a RHEL license or Cray license, you could just point at your own local repository or the one they maintain that you just enabled access to and be able to build it yourself.
Okay. My other question is, I've heard a lot, when I hear about containers, I've heard a lot of complaints about like, especially with like the classic like layer-based containers, which I assume is more or less what you're doing.
No, well, the base containers I build are built with Docker because those are just very minimal. And then I build on top of that with Charliecloud. Charliecloud is not really a layer-based. They have their own caching step system that's Git-based.
Yeah, but you're still providing a base container that people are building on top of.
Yeah.
Yeah. So what I've heard a lot of is that what I've heard a lot of in the past is that people have complained that convincing their code teams, from security teams, trying to convince the code teams to rebuild everything on the new version of the base container so they can catch all the security updates. And like that's been an issue, and like code teams don't want to change anything and don't want to update their containers and yada yada.
Yeah.
And it's pretty all the way down. So I guess is this something that you see at Livermore? Is this something that's still an issue?
I mean,
do you have any idea of how to solve it?
It's not as much of an issue because it's much like our bare metal systems. They're just constantly being updated, and if you're not keeping up with it, then that's, for the most part, not our problem. Is kind of how we treat that. We'll dial it back if any very important code is broken and needs to get work done, but a lot of the time we'll just keep marching and just work with the code teams to figure out that stuff anyways. I think having these containers assists that in that you can get a head start on testing out new versions of everything. But I don't, and I guess on the flip side, I maintain the old containers. So if you are using an old version and something broke you on a new version, you can just use the container for the old one. So I'm enabling both, or trying to enable both use cases. But yeah, I mean, there's always someone who will come across a specific thing and they don't want to update to it. And so you have to find a workaround.
Okay, maybe as a follow-up, do you have any suggestions for like migration from one base container to another? Other than just start from scratch and do it again?
Yeah, I guess one thing that I found, because I've been migrating like Ubuntu-based things into a RHEL-based environment, trying to translate those package names has been kind of annoying. I discussed this last night with one of the spec devs of, it'd be nice if the spec package would say the different names under which these appear on apt or yum or DNF or whatever package manager or system might have. Like, what the hell provides this specific thing? Because it's almost never the same name. And maybe you need the devel, maybe you just need libs, maybe you don't need either, just the base package. And so that, getting over that has been one of the main issues when I've moved between environments. Otherwise, I haven't had too much problem switching the base OS for any of the applications I've tried.
Vendors have different OSs that are their favorite distribution. They're all different ones.
Which is why we bullied Cray into using TOS. Like, no, we're not taking some new crap from you. Use what we have. And it worked for the most part.
I think the, oh, sorry. Go ahead.
Do you find it sometimes that users can use these base containers for building stuff and then deploying it on machines separately?
So I don't have any users doing that now, but because the way the packages are installed in this, you can just take the binary out of it, put it on the bare metal system, and it will work. So that's what I do with the programming environment. I build it out in what is user TCE in the container, and then I just bottle that up, take it over, and drop it on the system, and it works. So yeah, that's another reason for making it more of a system representative container than doing something different and having to go through the pains of translating all that.
Yeah. I'm glad you mentioned that you're using building off of the UBIs, the RHEL UBIs, because that's a kind of question that I had, because correct me if I'm wrong, but I think the UBIs are actually like have a no-cost license, right? It's weird.
Yeah,
it's weird.
I don't fully understand the licensing setup, which is why I did the CentOS ones, just to steer well clear of it.
Yep, understandable.
Yeah.
We have Rocky on some of our systems at Sandia, some of the test beds particularly.
Yeah, we have like our institution, Georgia Tech, has like basically like complete buy-in into the Red Hat ecosystem. Like we're under the our research computing center is under like the Office of Information Technology, and we've got like a really big license for Red Hat, which is nice for a lot of the admin tools, but it's like, kind of, it's things, it's questions like this, like what exactly can we do with this license? Where can we use this? If we want to use this at different systems, like if we want to do cloud bursting or something, like, are we actually violating the license? Then the license is really a moving target, as probably all of us know.
And I think we've looked into it, and different people on teams have read into it. It's just like different interpretations every time someone reads the license. It's, yeah, that should work for us. Or, so, yeah.
Okay.
Well, we pay for a lot of licenses, so I think it's more the reverse that's the question, right? Not that way.
There's a question from Jenna in chat saying, is your PyTorch performance work needed, specifically because of Ripple or also on Nickel?
So we've only just gotten non-PowerPC CUDA machines, and at the moment we don't have the time to put into trying out different modifications of the CUDA builds. So we're just telling users, just pip install, and that's usually CUDA enabled, and that'll probably work for you. ROCm, we're highly motivated by LCAP to get ROCm-based things working, and we've made a lot of progress on that so that my build is usually pretty performant, and then we've got other things that are beyond exactly the scope of the PyTorch build, like different settings to toggle when you're at runtime that are influencing the performance. So yes, getting it to build specific for our system and then be performant using our fabric and GPUs has required our local builds of PyTorch.
Anyone else have any questions? We have time for one or two more.